Okay, so in this video I'm going to go over review station number 5. I'm going to talk about how to convert equations and how to solve using those conversions. So we're starting with the first problem here. It says solve the equation by completing the square. Completing the square is where I want to go from general form to vertex form. And so I want it to look like this. I want my final function to look like this. Y equals a x minus h quantity squared plus k. This is what I'm trying to shoot from, and I've been given it in general form. So what do I do? Well, I'm mainly going to focus on the x squared plus the 4x, because that's what I am completing the square. I'm trying to come up with a square so that that becomes a perfect square binomial. So I'll move the 9 off to the side. So what I want is I want something so that I can add a number out here such that when I multiply my two binomials, and they need to be the same binomial, I get them to add up to 4, and then they're going to multiply to this number out here. So if we just do a box, we can see what that would look like. It's going to be x plus 2, x plus 2, right? I need half of this number. So that would give me an x squared, 2x, 2x. That gives me my 4x. But then I'm also going to get this value 4. So if I rewrite this as x plus 2 squared, which is heading me towards this, I have added an extra 4 in here. So I have to balance my equation by subtracting it, all on the same side. And then, of course, when I combine like terms here, I'm going to get x plus 2 quantity squared minus 13 equals 0. So now I'm in vertex 4. I have completed the square. Now I just want to solve, because remember it says to solve this equation. All right? So I'm going to solve, and by doing that I just have to add 13 to both sides. And I'm going to get x plus 2 quantity squared equals 13. How do I undo this? I'm going to take the square root of both sides. What I'm really doing is I'm saying, what could possibly have multiplied by itself to get me a 13 here? Well, there's the possibility of a positive and a negative answer. All right? Well, what's the square root of 13? I'm in here, and we're going to do the square root of 13. And I get can't quite see that, 3.6, and I'm going to round it, 3.61. So I get x plus 2 equals 3.61. That's the square root. But wait, it could also have been x plus 2 equals negative 3.61. So now I have my two equations here. All I have to do is subtract 2 from both of them. And over here I'm going to get my x equal to, and I'm sorry I'm running out of space, x equal to 1.61. But over here I'm going to get x equal to negative 5.61. And there we go. Those are my solutions. X equals 1.61, x equals negative 5.61. All right, there's another way we can solve, and we can solve by factoring. Okay, so when we factor, we want to get it in this form. Y equals a x minus r sub 1, x minus r sub 2. That's the form we wanted in from general. This isn't even quite in general now, because in general we want ax squared plus bx plus c. Well, that's going to require getting everything onto one side. So I'm going to get the 30x to the other side and the 40x over to the other side by subtracting 30x and adding 40. And then I'm going to arrange this in general form. 5x squared, oh, that's an x right there, minus 30x plus 40. And of course what I was left with here was simply 0. That's going to be important because I can't solve if I don't have it equal to something. All right, now I want to factor this. Oh, I don't like factoring with a leading coefficient here that's different than 1. But if I look carefully, I think, oh, I can save myself some time. All of these terms have a common factor of 5. I can factor out of 5. I get 5x squared minus 6x plus 8 equals 0. Now it's a much easier thing to factor, right? So what is it going to look like when I factor this? I've got my x squared here, I have an 8 here, and what I need two numbers that multiply to 8 and add up to a negative 6. Well, it seems to me that with the factors of 8, I have what, 8 and 1, 4 and 2, it's got to be the 4 and 2 combination. And they both have to be negative. So when I do that, I get 4x here, that's a negative 4x, and I get negative 2x here. Alright, so when I factor this, it's 5 times x minus 4, x minus 2 equals 0. It asks me to solve. How do I solve this? I need values that will make either set of parentheses equal to 0. Well, the value here that makes this equal to 0 is a 4. 4 minus 4 is 0. So x could equal 4. And over here, if I have a 2, x equals 2 gives me a 0 there. When I multiply that through, I get a 0 in the end. So x could also equal 2. So those are my solutions right there for this equation. Now, I want to convert to general form. I'm in factored form. Some of you know how to FOIL. I always fall back on my box to make sure I don't make any mistakes. And it's going to be 8x plus 2 and 4x minus 2. I multiply these, I get 32x squared plus 8x and minus 16x and minus 4. Okay, so I'm going to combine all my like terms. I get 32x squared minus 8x minus 4. There we go. That's general form right there. The last question is asking me to convert from what is vertex form to general form. And what I do here to remind myself is really what it's asking me to do is this. To break this into two terms that are being multiplied by each other, two binomials, I should say. X minus 5 plus 7. This is the same as that. And now what I do is I do my FOILing first, or box method. I'm going to do x minus 5, x minus 5. And I'm going to get x squared minus 5x minus 5x plus 25. I get x squared minus 10x plus 25. But remember, I need to multiply this whole thing by the 3. The 3 still has to multiply. And of course, I'll add the 7 at the end. I get 3x squared minus 30x plus 75 plus 7. My final answer is 3x squared minus 30x plus 82. Alright, and what goes on the back? Alright, so it wants me to identify some parts of these quadratics, to actually graph them out. Well, this is nice. This is given to me in vertex form. So as soon as I see something in vertex form, I know what my vertex is, right? My vertex is at negative 6, negative 1. Alright, so negative 6, negative 1, that's the vertex of my parabola. Okay? Now, I also see that my parabola has been flipped down. Okay, so it's going to open down like that. And it has been stretched by 2. So normally it would go over 1, down 1, but this has been stretched by 2. So it's going to go over 1, down 2, and then it's going to go another over 1, down 6, like that. So here we go. So, again, what's my vertex? My vertex is at negative 6, negative 1. My axis of symmetry. Well, the axis of symmetry is just the line that the vertex goes through. And so my axis of symmetry is x equals negative 6. It's this line right here. Alright? And I want my y-intercept. Ooh, my y-intercept is the point where the graph crosses the y-axis. In other words, where it is equal to 0. Well, the way I can do that is just plug a 0 in for my x. Negative 2, 0 plus 6 squared minus 1. That's just 6 squared. That's 36. Negative 2 times 36, negative 72. Negative 72, negative 1, negative 73. So apparently I have to go down pretty far, don't I? I have to go down to a negative 73. Y equals negative 73, or 0, negative 73. That is my y-intercept. And then I need the x-intercepts. Well, wait a minute. If I've done this correctly, does this cross the x-axis? It doesn't cross the x-axis. And I could actually tell that by simply plugging in this equation and solving for 0. If I do that, I get 0 equals negative 2 x plus 6 squared minus 1. I'm going to add 1, add 1. So I'm going to get 1 equals negative 2 x plus 6 squared. I'm going to divide by negative 2. Divide by negative 2. Negative 1/2 equals x plus 6 squared. Now I'm going to take the square root of each one of these, all right? Ooh, the square root of negative 1/2, though, that's impossible. You can't get the square root of a negative number. Hence, this does not cross. Turns out that they're imaginary. We can't graph them, okay? You would either pick it up this way or you'd pick it up in your graph, all right? So, no x-intercepts. And there we go. And we've got the sketch of my graph. Now let's do this one. This one's a little different because this is given to us in factored form. Factored form is nice because I simply know where my x-intercepts are right off the bat. Does this cross? It sure does. It crosses at 4 and it crosses at 1. And so I know that the roots of my equation are here. And what am I going to do next? So I've got my x-intercepts. X equals 4, x equals negative 1. Okay, I've got those. Let's start thinking about the vertex. Well, I can't get the vertex until I get the axis of symmetry here. The axis of symmetry is going to run right between these 2 points. So what I do is I say, all right, I've got a point at 4, and I've got a point at 1. And did I do this wrong? This should have been negative 4. No, it should have been positive 4 and positive 1. My apologies, I was moving fast. Positive 4, positive 1, and that's what I've got right here. So I want this axis of symmetry, right? And so I've got a 4 and a 1. I want what's halfway between them. And so if I just add those up, 4 plus 1, divide by 2, I'm going to get 5 over 2, or 2.5. My axis of symmetry is x equals 2.5. And that's this line right here. All right, now I've got my axis of symmetry, which means that if I have an x value of 2.5, I can get my y value, which is going to be my vertex. It's the only value that sits on that. So what do? I take 2. I'm going to plug in 2.5 minus 4, and then again 2.5 minus 1. I plugged in my value for x. And so what do I get here? I get negative 1.5. And then here I get a positive 1.5. And I'm going to multiply those times 2. And I don't trust myself because it involves decimals. So I turn on the calculator. And I'm going to do 2 times negative 1.5 times 1.5. And I get negative 4.5. All right, so that means my vertex is at 2.5, negative 4.5. Negative 4.5 is right there. All right. And again, how do I get the y-intercept? The y-intercept is simply where x equals 0. So in order to do that, I'm going to plug a 0 in. So I get 2 times 0 minus 4, 0 minus 1, and that's 2 times a negative 4, negative 1, that's negative 8, that's positive 8. So my y-intercept is at 0, 8. Does that make sense in this one? Yeah, it does. Looks like it's right there. And there we go. There is my parabola. All right.